Welcome to the third video in this series. In the last video, I walked you through coding and testing the contact entity and creating some validations that we extracted into a utility class. In this video, I'm going to walk you through coding and testing the contact service, which will serve as a pseudo database in this project. If you look at assignment 3 in the Brightspace, or if you look at the course site that I created, you'll find that it has 3 requirements. It must be able to store entities, update entities, and delete entities. Now, I'll also show you a couple of ways to code this in the course site, and I'm going to walk you through one of those today. Another thing that I want to point out before we get started is the Module 4 journal that you will have to do. It actually brings attention to several key factors in coding your contact service in a quality way. So these are some things you want to keep in mind as you're working on the project, and these are things that I'm going to show you how we can work toward in this demonstration. So let's read through those first. To what extent was your testing approach aligned with the software requirements? So aligning your testing approach with requirements means taking into mind how your software is going to be used. So what mind frame or mindset will your user be in when they use this code? Because essentially we're writing a library or an API, right? It's not necessarily, it doesn't really do anything by itself, but it is intended to be used by probably another application. So we need to keep that in mind. And we also want to make sure that we are aligning our testing with the requirements in the sense that we are testing the requirements. We are verifying all of the requirements, ensuring that not only did we build the correct thing, but that we built the thing correctly. So verification and validation. The next thing is we want to defend the quality of our test using the basis of code coverage. So I'm not going to walk you through getting your code coverage in this video. That will be a 4th video, which will be quite short because it's a very simple process in in Eclipse. But I will show you how to test your code, and then in this 4th video, I'll show you how to check the thoroughness of your test. And then third, we want to ensure our code was technically sound. So I will show you one thing in particular that we want to keep in mind is thread safety. So that is something I will show you how to code for in this demonstration. And there are other ways to make sure your code is technically sound. But that is one that I'm going to show you. And also I like to show you that because it shows you some of the more advanced features of Java without getting overly complicated. And then finally, how is your code efficient? So you'll have to talk about how did you ensure your code is efficient. I will show you a few ways to do that in both the actual source code and the test code today. One of those, of course, takes into consideration the data structure that we will be using. And then the other is how can we consolidate some of our tests, which we actually looked at that in the 2nd video, the one before this, where I showed you how to use parameterized tests in JUnit. So that is one way to ensure you have efficient test code. That being said, let's jump into Eclipse. So in the last video, I did show you how to partially complete your contact entity and the contact test. Of course, I went ahead and completed that in my code, so all of the testing and the actual source code is complete here. And I'm going to follow a similar approach in this video as far as testing goes. We will complete the contact service, and I will show you how to start the testing of that. So let's jump into it. We're going to go into the org/snoo CS320 contact package. We'll also be working in the same package, but in our test code down here. In the actual source main directory, we're going to create a contact service in the contact package. So we'll create that. We are, of course, using a test-driven development approach to our work. So let's go ahead and create our contact service test as well. So we're down here in the source test Java directory. In the same exact package as the contact service, we're going to create the contact service test. So one thing I want to point out is in the interest of creating technically sound code, we do want to make our software thread safe. And so I'm going to use something called the Singleton Pattern. If you are in the computer science path, then you have probably been exposed to this in one of your other classes. And what that means is that we're going to code this contact service class in such a way that there can only ever be one instance of it. And so we will create a variable to store that single instance in, and it's typically just called instance. You'll see that in the different examples. That is generally the name people use when they code the Singleton pattern. And another interesting aspect of the Singleton pattern is the constructor of the object is always private, prevents anything other than the object itself from creating an instance. And that ensures that when the instance is created, it's only created once. So you don't have threads interleaving amongst each other in the order of execution, possibly creating multiple instances of this particular object. And then there will be a method called getInstance. And an interesting aspect of getInstance is that it is a synchronized method, and that ensures that only one thread at a time can execute it. And that is important because it is the job of getInstance to control access to that single instance and create it the first time when it is needed. So it is created in what we call a lazy manner. It's not created until it's actually needed. And so we test to see if the instance is null, and if it is, we create it. And because we are inside ContactService, we can invoke that private constructor. And then finally, whether it had to be created or it already existed, we always return that one and only instance. So that is the beginnings of our Singleton pattern. At this point, we have enough code that we can go and test the code. We will flip over here, and what we want to do is make sure that it does get created. So we'll create a void and call it test get instance. And let's assert that contact service dot. And notice I made get instance static, so I can invoke it without actually having an instance of contact service. And of course, we'll just say that it's not null. Now remember, I'm going to import this, and my Eclipse is configured to suggest that to me. Yours is probably not, so you will need to enter this import statement yourself, and I'll put it in the lower thirds for you. We'll go ahead and save that. We'll save our test, and now we can right-click on this. Oh, before we do that, we have to add our JUnit Jupyter test annotation. Make sure you use the Jupyter version of it. And now we can run this by right-clicking on the class name and choosing Run As JUnit Test. And you see our one and only test does pass. So the next thing that we want to do is we want to create the resource that this Singleton pattern is protecting. And generally, that is what the Singleton pattern will be used for. It will sort of mediate access to some shared resource in the application. In this case, that shared resource is going to be our database. Now, that leads us to an important question about what data structure we use for the database. And this is very important because if you go with something like a list, an array list, or an array, while you are looking at with the array list or the array, you're looking at big O1 access time to fetch the object in an array. The same is not true when you are inserting into the array. And if you are looking at the performance of a list, it is big O of 1 to add an element to the list, but then it is big O n to fetch the element, particularly if you don't know, the index of it, then you're going to have to scan the entire list for that element. If you do know the index, you might be able to find a more efficient way of getting to it more quickly, maybe starting at the end or something like that, and going to it. But regardless, there are implications on the performance of the application based on the data structure we choose. Now, in this case, what we would like is big O1 access time to get something out of our data structure, and the same to put something into it. And of course, a map is the best option for that, specifically a hash map. Now, you know, of course, there is a downside. Everything's a trade-off, and the trade-off is it does occupy more disk space, or memory space, I should say, because it, you know, a hash map has to store hashes of the keys that you use to identify the elements you're looking for. And so there is more space there. It also has to use additional, I guess you would call it, say, nested data structures, because essentially it's going to take those hashes and it'll create a certain number of buckets that each hash will index into, and then within each bucket it will have a nested data structure, perhaps a list or something like that. And so once it indexes into the bucket, then it'll go through that nested data structure to find the element you're specifically looking for. And, you know, that's a very layman's explanation of it. I'm certainly no expert on all the different implementations of these data structures, but just know that, you know, this is the best option for our needs. And so we will create a variable to hold that map. We'll call it database. And it will be a concurrent hash map, meaning it is thread safe. So only one thread at a time can manipulate this. And then we'll import map as well, save our changes. And notice I left this as package private visibility, meaning any other classes in this same package can see it. And that's important because we do want to be able to access it directly from our test. And I'll show you why later. So this is package private, but that's really not a big issue because anything in our contact package we can trust that it won't do something nefarious. So now that we've got our database and our mock database, not a real database, but it is our database for the purposes of this assignment, we can start implementing some of the methods. And the first one we're going to implement, of course, is add. And I'm going to set these up so that they return true if they succeed. They return false if they do not. But before we actually implement these, we're just going to throw a new unsupported operation exception, because this is sort of a placeholder, meaning, hey, while it doesn't do anything yet, it's coming soon. And we'll do the same thing. We'll go ahead and code the other two methods that our requirements called for. And so delete should delete by the ID or the map key in this case. Of course, we'll throw the same exception here. And then our last method is the update method, and it also takes an ID. And then it takes the contact object with the changes we want applied to the object identified by this ID that is stored in our database. So that is how we'll pass in the changes to those fields using this object. And then finally, we'll throw an exception here as well. So unsupported operation exception. Now we can flip over to our test, and we're first going to implement the add method. So let's go ahead and, in our test-driven development approach to this, we will write a test for the add method, and it, assert that it behaves the way the requirements call for. So in this case, we will create a contact, and we'll just name it contact, and that new contact will have just some dummy data, which I'm going to copy in here for the sake of time. And the next thing we want to do is we will attempt to add that. So we'll use our assert J method, and we'll say ContactService.getInstance.add. So see how the Singleton pattern works? And of course, we will add that contact, and we want to assert that our add was successful and return true in this case. Remember in the last video that each of our constructor and our setters all potentially throw a exception, and so we need to declare that because it is a checked exception, meaning that we have to either declare that it could be thrown or handle it with a try-catch block. And then finally, we want to assert that our database contains the object that we just added. So we'll say get instance, and now remember we kept the database package private, so we can't access it here. And we'll use assert J's method that contains entry. And so we'll say, it contains the entry identified by 1, 2, 3, 4, 5, and that entry should be contact. So it should be the same one we just added here. So pretty comprehensive test right there, right off the bat. Don't forget our test annotation. And then let's run our class again just to ensure that it does fail as we expect. It does. And you see that an unsupported operation exception was thrown. All right, now that we've got our test written, let's flip back over to the contact service and implement this method. So the first thing we want to do is put the new value into the hash map, and we're going to use a special method called putIfAbsent to do that. So we'll say database.putIfAbsent, and the putIfAbsent, what it does is it only adds this new value into the map if the key that we provide does not already exist in the map with an assigned value other than null. So if the key is in the map but it has null, this will succeed. If there is no key in the map matching this ID, it will still succeed. However, if there is a key in the map and it has a value other than null, then this will fail. And when it fails, what it does is it just returns the value that's already in the map with that key. If it succeeds, it returns null. So we will return the comparison between our putIfAbsent calls return value and null. In other words, we're saying if it's null, return true, meaning that it succeeded. And that should satisfy our test. So let's run that. And you can see that it did satisfy the test and we're passing. So let's go ahead and add our next test for the delete method. So we'll call that test delete. And we'll go ahead and copy down this code from our contact that we create. We'll say assert that, and we want to, in fact, we can copy this as well. We want to assert that we successfully insert this into the map. And then we want to delete it and assert that our delete is true. So we'll say ContactService.getInstance.delete by the ID we specified is true. Okay. Left out a quote there. And then finally, we want to assert that the value no longer exists in our map. So we'll get our instance. And remember, we made database package private, so we can get the database. And we'll say does not contain the entry 1, 2, 3, 4, 5 with our contact value. And then, of course, we need to add our throws declaration, and we'll save that. And let's run our test. Should fail this time. It does. So let's flip back over. All right. Oh, we have a bug here. Notice that. It never did make it to throwing our unsupported operation exception because it failed at line 26 where we added, because that add returned false. And apparently our contact with 1, 2, 3, 4, 5 was still in the map. And you know what? That is to be expected. What we need to do is before each of these tests run, we need to clear out that map. So we can say ContactService.getInstance.database.clear so that we start with a clean database every time we run a test. Of course, we need to import that before each annotation. Let's try it again. We should get an error still, but it should be that unsupported operation exception. There we go. So that's what we expect. So we can flip back over here and implement our delete now. So we'll return database.remove. And we want to remove that key. So it'll be the ID. And let's see what, so the remove method, it returns the value of the entry you remove. So if we remove an entry that matches our ID, this will return the value. If it does not exist, it returns null. So in this case, we want to say that it is successful if it returns something other than null. Okay, and that should satisfy our test. So we can run this again, and they all pass. So now we'll write our final test. In this case, it'll be a test for the update method. And I'll go ahead and add this throws declaration so we don't have to deal with that later. And in this case, again, we want to copy down our contact. Again, we want to verify that it was successfully added. This time, we want to also create a new contact called updated. And we're going to leave the ID empty. Well, we can't do that because our validations will fail. So we'll just set it to something we wouldn't expect. And we'll name, because ID doesn't matter, remember, we're copying everything but the ID over. And so we're going to change the name to Bob. We'll change the last name to Barker. The phone number can be something completely different than what we have. And then we'll make this 5432 test lane. And we want to assert that ContactService.getInstance.update by this ID. And we're going to use the updated's values, and we want to make sure it's successful or true. And then finally, we want to say contact will assert that, and this time we're going to use that database, direct access to our database again. All right, and we're going to extracting. So extracting means we're going to actually move our assertions from directly onto the database to a value we get out of the database. And we're going to extract the value identified by our key, and then we're going to use that has field or property with value to assert that our values were applied to it. So the first one's going to be the first name. First name should now be Bob. Last name should now be Barker. Phone number should now be 999-777-1111. And finally, the address should be 5432 test lane. Let's run our test, confirm that we get that unsupported operation exception. We do, and now we can go implement our update. What we're going to do is we're going to get, we'll call this existing. And this will be a contact. We're going to get the value as it stands in the database. So database.get. We're going to get it by the ID. If we don't find that, we'll return false because it doesn't exist. But if we do find it, then we're going to apply the values from the updated copy passed in. So we'll set first name to updated.getFirstName. We'll set the last name to updated.getLastName. Set the address to updated, get the address, and the phone. And then, of course, all of these throw potential checked exceptions, so we have to add that. And then finally, we'll return true at the end. And remember, our setters also validate the data, so that guarantees that we are enforcing those invariant conditions required by last week's requirements. And if everything's successful, we return true. And now we can go back and run our test again. It passes, so we've satisfied the requirements. So at this point, our contact service and test are complete, at least as complete as I'm going to make them in this video. I do expect you to test the failure paths or failure scenarios in the service as well. In other words, if you attempt to add a contact that already exists, you need to test how does this service react to that. Does it behave as expected? Same goes if you try to delete a contact that does not exist by ID, or if you try to update one that does not exist by that ID. How does that behave? Or if you try to update one with bad data, so can you do that? I don't know. That may be a little difficult because the setters and the constructor all enforce those invariants. So you may not be able to test that, but just go through and try to test as many of those failure scenarios as you possibly can. With that, I'm going to close this video out. I invite you to tune in to the fourth one where I talk about your code coverage a little bit. So I will see you there.